Let me start by creating a new data pod in Lucid. I'll name this data pod Life Sciences and CRO Data Hub. Life sciences and CRO organizations manage extremely complex and regulated data environments, spanning clinical trials, EDC systems, CTMS, EHRs, safety systems, labs, imaging, supply chain, finance, and regulatory reporting. I'll select the industry type as life sciences and clinical research operations, so Lucid understands the industry context right from the start. Traditionally, transforming this data into analytics-ready, this data pod is designed to show how Lucid accelerates that entire journey. Next, I'll configure the data domains for this data pod. These domains represent key functional areas across life sciences and CRO operations. You'll see domains like training and development, clinical trials management, quality assurance and compliance, data management, ethics and IRB oversight, medical writing, patient recruitment and pharmacovigilance and safety. For this demo, I'll focus on clinical trials management, which is central to trial execution, monitoring, and reporting. Here, Lucid generates a disk-aligned industry data model using an AI-assisted, prompt-driven approach. This removes the need to start modeling from scratch. You can see here I am providing a custom prompt to Lucid to align the data model generated to disk industry model. Lucid automatically generates core clinical trial entities such as clinical trial, protocol, site, patient enrollment, adverse events, visits, study arms, investigational products, trial results, and regulatory submissions. These models are already aligned to industry standards, and we can also add custom tables if needed. For this demo, I'll select the clinical_trial and patient_enrollment tables and further expand them to generate detailed attributes, descriptions, transformations needed for analytics and KPIs. You can also define a custom attributes by add new attribute features. Next, I'll add a raw data source. This data source represents our clinical trials raw database from Microsoft Fabric, which is a bronze layer database containing unprocessed patient, visit, and laboratory data. Once the source is added, Lucid automatically generates context for the data. It understands that this is a raw clinical trials database used in life sciences and clinical research operations, supporting patient-level and trial-level activities. This step is important because it allows Lucid to reason about the data before any transformations are built. Now Lucid runs AI-driven profiling on the raw data. Here, Lucid analyzes the datasets and automatically derives column meanings, data patterns and quality signals. Instead of engineers manually inspecting tables and documenting columns, Lucid provides an instant understanding of what the data represents and how it can be used. This significantly reduces the data discovery and onboarding effort. Next, we move into AI-driven data mapping. Lucid automatically maps the raw source data to our disk-aligned target models, specifically the clinical trial and patient enrollment tables. The AI understands how source fields relate to standardized trial concepts and proposes mappings that would normally take weeks of manual work. This ensures consistency, repeatability, and alignment across studies and trials. Once the mappings are in place, Lucid identifies relationships across entities. Here, relationships between trials, patients, visits, and sites are automatically detected. This ensures accurate joins, lineage, and analytical integrity, without engineers manually guessing how tables should connect. Now we generate the ETL pipelines. Lucid automatically generates the ETL and ELT code required to move data from bronze to silver and gold layers. What's important here is vibe coding, meaning when changes happen we only update what's needed instead of regenerating everything. This dramatically reduces rework and makes ongoing iteration much faster for data engineering teams. The great part of this feature is the ETL code that is generated and updated by Lucid Agent is committed to your own source code repository such as GitHub and Azure DevOps. You can roll back changes, maintains history and change capture. Finally, we define business use cases and KPIs. The selected use case is real-time trial monitoring, which supports dashboards for tracking enrollment progress, site performance and milestone completion. Lucid recommends the relevant tables, clinical trial and patient enrollment, and helps us define KPIs such as average enrollment per trial and many more. This KPI calculates the total actual enrollment across trials divided by the number of distinct clinical trials, helping teams evaluate recruitment efficiency. Lucid automatically generates the KPI formula, code that implements the calculations and finally loads the KPI values as pre-calculated data in gold tables. At this point, we've gone from raw clinical data to standardized models, automated pipelines and business-ready KPIs, all in one connected flow. In just 16 minutes, this demo shows how Lucid enables life sciences and CRO teams to move from raw clinical data to disk-aligned models, automated pipelines and real-time insights, faster with less manual effort and with built-in structure for compliance and scale.